So we're trying to compute this area, and I was commenting just now that the two integrands here, this is a minus b, and the other one is the b minus a. If you haven't noticed this before, I don't know the class where they tell you this fact. A minus b is the opposite of b minus a. If you distribute a minus into here, you get negative b and positive a, which is a minus b. So these two functions are the same function off by a minus sign. When I integrate them, I will get the same answer off by a minus sign. So I'm probably never going to type this function in. I'm just going to integrate the one function over that region and accommodate the minus sign myself. Let's try and calculate this. So now, instead of graphing those two functions, I'm just going to turn off the graphs. If you hit enter on the equal signs, you can say, hey, don't bother graphing this one. I'm not thinking about that right now. What's the main function? It's x minus the other function is, wrap it up in parentheses, 10x to the fourth minus 9x squared plus 3x. I need to make a graph. And I need to tell the calculator to calculate the integral from, the first one is from negative 1.0447 to 0. So that first integral is 2.0231. Oh, also I have a minus here instead of a plus. I don't know why that is. It was those three regions, add them up. So I want this one plus the last one. I'm going to do the last one first because it doesn't involve the switcheroo. Like, I want x minus the x to the fourth thing, and that's the thing I have graphed. So I want to calculate the integral from 0.237 is my lower limit. My upper limit is 0.8077. Now it's doing that area, and it's getting 0.2586. And then what's this middle one? The middle one is the integral of a different function, but that function is just the opposite of this function. If I compute this integral, I'm going to get a negative number, 7. I want to go from 0 to 0.237. This one's going to give me something negative. It's giving me negative 0.0177. But I'm going to make it positive because that was the opposite function. So it's basically taking, hey, the thing I'm ending up with is this area, this area, this area. When I ask for the integral of this area, it's spitting out a negative, and we are manually making it positive. Because the question they asked is find the area. The integral counts stuff as positive. When we use the word area, everything counts as negative. So our answer is you add up these 3 numbers and you get whatever you get. I don't actually care what the digits are right now. And that's the answer to that one. And that's the area bounded between two curves. It's the integral from left to right of top minus bottom. Sometimes you'll use your calculator to find the digits of what are the points. Sometimes you need to think about what's the top, what's the bottom. If they switch, you have to cut it into smaller pieces. That's the area one. I still got 7 minutes left on this video. I'll move on to the next topic. The next topic is the fundamental theorem of calculus. Math is made up of theorems. A theorem is a mathematical statement that has been proven to be true, and there's like a few of these fundamental theorem of blanks. There's a fundamental theorem of arithmetic and algebra and calculus and ergodic theory and Galois theory. I guess the ergodic theory one, they don't call it that. But I don't know. There's these highfalutin names. The fundamental theorem of calculus is saying a thing that we've kind of already dealt with before. When we talked about the integral for the very first time, it was saying suppose you have the derivative. So if big F of x, if the derivative of big F of x is little f of x on an interval from a to b, then when you integrate the little function, the derivative, from a to b, the point of it was I know the rate of change of something, That should tell me, if I know exactly how fast you went at every moment, then I should be able to figure out how far did you go. And that's what this thing gives us. The integral of the rate of change gives the total change. You know how far you went for every second. You add that up and get how far you went total. So the thing you end up with is, how much did big F change by between A and B? And the answer to that is, well, it's f of b minus f of a, whatever that is. It could end up being negative, which is why sometimes you end up with these negative area jazz. If the derivative was mostly negative, you were decreasing mostly, so you end up with a negative answer. But yeah, this is called the fundamental theorem of calculus. It's not really a deep thing right now, because it's the thing we were talking about, but we're using this to answer different questions. For example, if g prime of x is x to the 8 minus 4x squared, and if g of 3 is 7, then what's g of 9? Well, this is a situation where I know how fast g is changing, I know what it started at, what's it going to equal at the end? This is one of these situations where I know exactly how fast you were going. Remember, the first thing we talked about with an integral is, I said the town's increasing by this much. Now, what's the population at the end? And the answer was, it's a trick question. Knowing how fast it's changing isn't enough to tell you what the value is at the end unless you know what the value was at the start. This is them giving us what the value was at the start. It doesn't need to be at the start. It could be at the end or whatever. Anyway, the thing we are using is that the g of 9 minus g of 3 equals the integral from 3 to 9 of the derivative. Right? If I know the rate of change of the thing, integrating it gives me the total change of the thing. And that's enough to figure out the part that I don't know. Having this formula in your head as a thing you can write down to now plug everything in makes it pretty simple. You can just think in terms of starting value plus how much did you grow by between 3 and 9 gives you the ending value. And it's the exact same equation as this if you move something to the other side. I think it's nice to have this version of it written down in your head, and we'll use it a bunch more in the next exam's worth of stuff. Yeah, so I know all these numbers. Or g of 3, this is 7. This I don't know, but I can get my calculator to tell me. Hey, calculator. Y equals... How do I get my calculator to do an integral? I need to graph the function. What was the function? It was x to the 8 minus 4x squared. Oh, this is a very big function. I say graph it. Does my graph include the region from 3 to 9? No, it does not. Let's go to zoom 6, standard zoom. And I can say, hey, please calculate the integral from 3 to 9. And it's all up above the graph. That's okay. It matters left to right. Oh, geez, I got a ridiculous answer. I made a bad choice of function here. Our answer was, what is that, 4 million something? That's 43,043,598. When I add 7 onto that, I'll get 43,043,605. So you add 7 onto the integral. That's what you get. There's many versions of this. Like, one of the things I can do is, if I know the derivative of some function, let's make it something simpler. Let's just make it the square root of x. And if I know... Wait a minute, hang on. Is that one of the problems? Let me go find something I didn't put